So looping back around to our original question of what is aquaponics, we've looked at aquaculture a little bit. We've seen some different ways that fish are reared around the world: cage culture, pond culture, tank culture in recirculating aquaculture systems. We've looked at some of the broad benefits of hydroponic growing: increased productivity per square foot, less water dependency or less consumption of water per pound of produce yielded. And now we want to start looking at how we marry those two things together, how we connect fish culture to hydroponic production. And so often we'll see a diagram of an aquaponic system that looks similar to this. We'll have a fish tank with some sort of fish, either tilapia or koi or fancier fish like barramundi in them. And the fish wastewater, this nutrient-rich, ammonia-rich wastewater, is cycled from the fish tank up to some sort of grow bed, whether it's a deep water culture grow bed or an NFT gutter system. And we'll dive into deep detail on both of those and when to use different types of equipment at different times. But for now, we see this fish tank and we have the fish wastewater cycled into grow beds, and the plants take the nitrogen out of the water, and that cleans the water, and that clean water can be returned back to the fish tank. And so we've got this pretty neat little cycle where we have fish producing wastewater, wastewater flowing through the grow beds, the plants remediating the nitrogen from that wastewater, and clean water returning back to the fish tank. And this is the diagram that most people think of when they just start learning about aquaponics. And this is what gets thrown around a lot in the aquaponic world, that if you take fish and fish waste and you cycle it to plant grow beds, they'll clean the water and your fish will have clean water. The fish will produce waste for the plants will clean the water for the fish, and it's a nice little symbiotic circuit like this. But where this starts to fall apart is when we talk about the reality of the real world nitrogen cycle. The nitrogen cycle, as it relates to aquaponic systems where waste is being produced by fish and plants are uptaking that waste, goes as so. First, we have ammonia, and ammonia is converted over to nitrites. Nitrites, the intermediate form here in this circuit, are then converted over to nitrates. So you'll often hear people talk about ammonia levels and nitrite levels and nitrate levels or concentrations in an aquaponic system. And you'll very often hear people talk about the transition from ammonia to nitrate within a system. And so we want to kind of take these different forms of nitrogen and lay them in on the diagram that we looked at before, so we can start to understand how an aquaponic system works and what small pieces of an aquaponic system are necessary to ensure the safe continued operation. The first thing that we want to focus on is the fish tank and the production of ammonia. Ammonia is the form of nitrogen that fish release in their waste. It's important to note that ammonia is toxic to both the fish and the plants. At the end point, we want our nitrogen in our wastewater to be in the form of nitrate nitrogen. Nitrate nitrogen is fish safe up to very high concentrations and is the form of nitrogen that plants can actually take up as plant fertilizer. It's important to note when we're discussing building aquaponic systems and operating aquaponic systems that the conversion from ammonia through nitrite out to nitrates that can be used for plant growth doesn't happen automatically. There are beneficial bacteria that convert harmful ammonia to nitrites, and then other beneficial bacteria that convert nitrites to nitrates. These bacteria, in my mind, are the most important part of an aquaponic system, and often the most neglected. It's very common when people are designing their first aquaponic system or building a small DIY aquaponic system to get caught up in the fact that fish waste is used to grow plants. That's not necessarily true. Beneficial bacteria that are cultivated intentionally in the aquaponic system circuit convert harmful ammonia nitrogen to usable nitrate nitrogen. Without these beneficial bacteria, we will just be cycling harmful toxic ammonia through our system. This will eventually lead to an ammonia spike that will kill off our fish and result in poor plant health and plant loss. As we work through the next few lectures in this aquaponic training course, we'll be discussing the role of bacteria in the nitrogen cycle in an aquaponic system. We'll also be discussing various ways that we can intentionally cultivate beneficial bacteria in our systems, and how we must, when designing an aquaponic system, build in the proper bioreactor spaces or bacterial culture spaces in our system in order to ensure that we have sufficient bacteria populations to convert the ammonia produced by our fish tanks into safe, usable nitrate nitrogen for uptake by our plant growing equipment.